JavaScript is famous for being a totally normal language that behaves exactly how you would expect. There's nothing in this language at all that is confusing. If you look at other weird esoteric things like Python or Ruby, you see these crazy syntaxes that make no sense at all. But in JavaScript, everything is logical. I want to go through and prove that by showcasing a bunch of totally normal behaviors that JavaScript does in totally normal ways. I think this is going to be real fun. We're starting with this GitHub repo. Very, very useful GitHub repo. WTF.js, hosted on Denny Dovan's GitHub. Link in the description if you want to read through this yourself. JavaScript's a great language. It has a simple syntax, a large ecosystem, and what is most important, a great community. At the same time, we all know that JavaScript is quite a funny language with tricky parts. Some of them can quickly turn our everyday jobs into hell, and some of them can make us laugh out loud. The original idea for WTF.js comes from Brian LaRue. This list is highly inspired by his talk WTF.js from over 10 years ago. And if I recall, that was inspired by What by Destroy All Software, which is another classic talk. This one's not on YouTube, so you have to find this by Googling for it. Absolutely legendary, super inspired by this. We're the same year. That's actually hilarious. We haven't had funny talks about weird language quirks for 12 years now. We're going to make up for that by making a YouTube video going through a bunch of the best things here. You can install this handbook using npm. Just run npm install -g WTF.js. You should be able to run WTF.js at the command line now. So open the manual in your selected pager. Otherwise, you may continue reading on here. We're just going to read through the page. Because as per always, JavaScript's a totally sane language that does totally sane things when it doesn't have the things it expects. Honestly, great start to throw some obscure error when you run the CLI. If somehow you even picked up on the fact that I'm being sarcastic, now's a good chance to. We're about to roast all of the weird things that make JavaScript so special. Quick, before we go further, the notation. This is meant to show the results of an expression. This is the result of a console log. And this is just a comment for an explanation. So simple syntax so you can see what the output is. Cool. You should get that. I want to dive right into the examples though, because this is where things get fun. Great start. Array is equal to not array. What? We're in for one. Explanation. The abstract equality operator converts both sides to a number to compare them, and both sides become the number 0 for different reasons. Arrays are truthy, so on the right, the opposite of a truthy value is false, which is then coerced to 0. On the left, however, an empty array is coerced to a number without becoming a Boolean first, and empty arrays are always coerced as 0, despite being truthy. Somehow even more cursed code. Yeah, the falsiness occurs before the number coercion. Why? Yeah, empty array is truthy, but not true. Apparently that comes up more later on. True is not equal to not array, but it's also not equal to array. So true is array, false. True is not array, also false. False is array, true. False is not array, also true. That's the Patrick meme, for real. For real, the wallet, like, is this your wallet? Is this your truth? I don't even want to try and digest that explanation. We're going to go straight to true is false. Not false equals not true, obviously true. Not false is triple equals to not true, also obviously true. Oh boy, we're in hell. I don't even know what this is. Oh, this is a funny game. I have to pass it something in order to make this return true. So that one's easy. You pass it true, you get back true. Oh, reflexive, x does not equal x. Fuck. Object. Fuck. I want to think of something good for this. Oh, Nan? Good instinct, chat. I stole that one from chat. I'll give them credit. Cool. Transitive. X and x equals y and y equals z and x does not equal z. But I do get to pass 3 values here. Fuck. I'm still stealing from chat. If this works, I'm going to be so mad. Nope. False. False. False? No, because the not equal is going to fail on that one. Okay, I need to check something quick. This is going to be such a cursed challenge. Let's test some theories here. Okay, so that was correct. How about false does not equal 0? What the fuck is this language? I retire. I lose. This seems just cursed enough to be right. Also, the 0, 0 false. I have to win this one, and then I'm moving on because it's going to drive me mad. What was the other one? Empty array, false, empty array. I hate this language. Mostly I hate double equals. Like, double equals is the most cursed shit. I hope this helps emphasize why we don't use double equals, because if these were triples, we'd be fine. I hate this. I hate this so much. I hate this language. I don't want to consider this step by step. Okay, I do want to consider step by step. How this makes any sense, I have to know. So true equals true is false. False equals false is also false. So not false is true. Not true, also true. Okay, that is dumb. Good old banana, everyone's favorite nans. The better version of this example I like is if we have const x equals hello. I'll even add a space. Then we have x plus 5. JavaScript does the very logical thing of attaching the previous string to the number or whatever else we added. As long as the thing we add here can be interpolated into a string, you're good. If this is a 2-string, this works. However, what happens if we do x minus 5? Well, this spoiled it for me. Not a number. Why? Anyways. This is an old school joke in JavaScript, but remastered. Here's the original. Foo plus bar, foonan. Once you add an extra plus, the syntax gets way more cursed. Because putting a plus in front of something, by the way, if you didn't know this, if you do plus 15, that's a way to coerce something into a number. Really annoying syntax. I hate it. Just parseInt. It's free. It's right there. Same thing. And the classic, nan is not nan. Because nan is more of a state than it is a value. So nan does not equal nan. Does nan double equal nan? Nope. Double or triple equals, nan is not nan. So if you want to check if something is nan, it's number.is nan, right? Nan. There you go. We don't need to read the spec for that one. Chaotic enough as is. Speaking of is, object.is and triple equals have a bunch of fun weird cases. Object.is nan comma nan, true. Triple equals is false. Object.is -0, 0, false. -0 is equal to 0. Object.is nan 0 divided by 0, true. But nan triple equals 0 by 0. This is all just because nan is weird for at least the first and the third. Yeah, but this makes no sense. What? I hate this. I hate this so much. In JavaScript lingo, nan and nan are the same value, but they're not strictly equal. Nan triple equals nan being false is apparently due to historical reasons, so it would probably be better to accept it as it is. At least they're being realistic here. It's better to just accept it than to question it. Similarly, -0 and 0 are strictly equal, but they're not the same value. So what's fun with -0 is that you can't get to -0. There's no way to start let y equals 5. Y equals -0. You can assign something to -0. But what happens if I y plus 1 or y equals y plus 1? Now it's 1. Y equals y minus 1? We're back to 0. Why the fuck is there a -0? Oh God, if what people are saying in chat right now is true, const z equals 0 times -1. I hate everything. I'm going to be a farmer. Yeah, -0 is not a thing that I will ever concede to being a good thing. You never believe this, but oh God. Is this because of array coercion being coerced into a string somehow? By breaking the massive symbols into pieces, we notice the following pattern occurs. False, true. Oh. They spelt it by accessing the letters in false and accessing the indexes on it. That is so cursed. The rest is obvious, but the I is tricky. The I in fail is grabbed by generating the string false undefined and grabbing the element on the index 10. Ugh. More examples. Every single one of these hurts my brain. Every single one of them. This is making me reconsider everything. Maybe Go is a good language after all, because you can't do any of this shit there. What would a what the fuck for Go look like? Oh, I know what the what the fuck for Go would look like. This is an article by Faster Than Lime, lies we tell ourselves to keep using Golang. And has this one section that has been rotting my brain for quite a while. The channel axioms in Go: a send to a nil channel blocks forever, a receive from a nil channel blocks forever, a send to a closed channel panics, and a receive from a closed channel returns the 0 value immediately. I do not know how anyone can justify any of these behaviors. Ugh. Anyways, back to JavaScript. Null is falsy, but not false, obviously. Not null is false, but null not equal to false. 0 equals false is true. Empty string equals false, also true. So why is null treated falsely differently? You can double negate null and get false out of it. So it understands that null is falsy, but it doesn't coerce it with double equals. Again, double equals is I'm just going to search double equals space on both sides, so we know it has to be 67 instances of double equals with spaces on each side. And we change it to triple equals. There's less than half as many because it's so much more common. Because double equals is just evil. Anyways, Don't say this actually makes sense about anything in here. Document.all is an object, but it is undefined. This is part of the browser API and it won't work in a node environment. Cool that we're not testing that there. But God, I did see this one earlier and this seems awful. Document.all is an instance of object. So document.all is object. Cool. Makes sense. Document.all being an object is logical. Type of document.all is undefined. But if you check if it's undefined, it's false. You check if it's null, also false. But if you do it with double equals, why? Then you cannot explain this one. You're not going to convince me that this ever made any sense. Document.all used to be a way to access DOM elements, in particular with old versions of Internet Explorer. While it has never been a standard, it was broadly used in the old age JS code. When the standard progressed with new APIs, such as document.getElementById, the API call became obsolete and the standard committee had to decide what to do with it. Because of its broad use, they decided to keep the API, but introduce a willful violation of the JS spec. The reason why it responds to false when using the strict equal comparison with undefined while true when using the abstract equality comparison is due to the willful violation of the specification that explicitly allows that. So they're okay with this because it's obsolete. Minimal value is greater than 0. Number.min value is greater than 0. Cool. Number.min value should be the smallest possible value. How does this compare to infinity? I have questions now. Const min equals negative infinity. Now I have some questions. Min comes through as negative infinity. Number.min value equals min. False. Fine. Less, also false. Are you kidding? And obviously, like 0 is greater than negative infinity because infinity behaves properly, but the number.min value doesn't. That is really dumb. Number.min value is 5e negative 324, i.e. the smallest positive number that can be represented within float precision. Oh, why is it the smallest positive number? Why? I don't know what the use of that is. Like, that just makes no sense. Anyways, what happens when you try to add two arrays? Joy. I did not know that one. It coerces them to strings and then adds the strings because it's effectively running toString on them when you do add. This is one of the weird JSisms. When you call add, you're effectively calling toString on the objects. So I have like const a equals toString hello. Const b equals toString world. Console.log a plus space plus b. In most languages, you define an operator. You define, in most languages, what happens when you add. In JavaScript, you just define what happens when you string. Isn't that beautiful? Isn't it wonderful that using the plus magically makes these functions get called? And if you're wondering, no, you don't need the space. I just put that there for the formatting. Just using the plus does this. But if you just use it by itself like that, it tries to convert it to a number, which it can't do. But if you do empty string plus a, now you're good. Wonderful language. Trailing commas in arrays. You've created an array with 4 empty elements. Despite all, you get an array with 3 elements because of trailing commas. I don't even want to think about that. Array equality is a monster. Array equality is a monster in JS, as you can see below. Don't compare arrays. Just don't do it. It's never worth it. This is never, ever worth it. You should be very careful for the above examples. The behaviors described in this section, abstract equality comparisons of the spec. Yeah, just don't compare arrays. It's never worth it. That's why we have isArray, so you can even know if something's an array, because an array is an object, it's not an array, type-wise. Joy. So we're a bit over a third of the way. This is going to be a fun experience, isn't it? Undefined in number. Just seeing those words together has me a little bit stressed. If we don't pass any arguments into the number constructor, we'll get 0. The value undefined is assigned to formal arguments when there are no actual arguments. So you might expect that number without arguments takes undefined as a value of its parameters. However, when we pass undefined, we'll get nan. This is so people say the problem with undefined is that we have undefined and null. No. The problem with undefined is that it doesn't actually mean undefined. You can't not define something and have it be the same as when you pass undefined to it. Explicit undefined is different from implicit undefined. So like, here's a fun one. If we do the example with the comma, so const first equals, do 2 in order to make sure it has the elements. So 2 empty items, even though we have 2 commas because the trailing comma, but we have 2 empty items. If I make another array, const second equals undefined, that is different. 2 empty items is different from 2 undefines. There are 3 bottom values in JavaScript. We have undefined, we have null, and we have true undefined. Ugh. Problem's that we have 2 bottom values. It's we have 2 we can access and 1 that we can't. If undefined was the same thing as empty item, or whatever the fuck you want to call this, cool. But we have undefined the keyword, and we've undefined the behavior. This also gets fun if you define a function. So if we define like function test func takes an argument z, console.log z. Test func, just call it. Cool. Test func undefined still seems fine. But if you actually try and use this internally, those are different things. It's such a fun joy. Also, yeah, if we go to that empty items array, that's fine, even though first is 2 empty items and second is that first 0 equals second 0. That's fine because they're both undefined. It's just different types of undefined. Type of, oh boy. What a beautiful language. Parseint is a bad guy. Parseint is famous for its quirks. Joy. That's because this is technically base 16 because of the star. Yeah. The F in fuck is the hexadecimal digit 15. But without making it base 15, we can't access this and treat it as a number. Annoying. To show this, because default parseint is base 10. So we call parseint with like 71 random text, we get back 71 because it's going to parse wherever it can. So if we do parseint, no, because it's trying to get the numbers off the front. So if we do parseint shit 16, no luck. But if we do like 26, how high does that number have to be in order for S to be valid? I don't care. We're going to do 16 because that's hexadecimal. And now we get the last value because hex is A through F. This one makes sense. I don't think this is that big of a deal. I'm curious where we end up here though. Parseint infinity. Okay, this is much more cursed. I hate this. 16 is max, he says. And then here. This explains a lot about the mental state of web devs. You're not wrong. I don't even want to think about this one. Oh, it's converting null to the string null and then trying to convert it. For radixes 0 through 23, there are no numerals it can convert to, so it returns nan. At 24, n is the 14th letter, so that's added to the numeral system. At 31, u is the 21st letter, and that is added, and the entire string can be decoded. Fuck all of this. Oh, even more fun. If you have a leading 0, different ECMAScript standards are going to handle it differently. Joy. If it begins with a 0, radix is 8 octal or 10 decimal. Exactly which radix is chosen is implementation dependent. ECMAScript 5 specifies that 10 decimal is used, but not all browsers support this yet. For this reason, always specify a radix when using parseint. Be careful while parsing floating point values, because it's going to coerce it to string. That's beautiful. That is beautiful. Math with true and false. I can already tell you do not want to do math with true and false. That's 2. So 2 times 2 is 4 minus true is 3. Also funny because 2 and true sound similar. So 2 by adding true twice times 2 by adding true twice minus true, which is 1, equals 3. Makes sense. Number.parseint and parseint are different. I fucking hate this language. This one makes sense. I think this is fair. I know people are mad that type of nan is number. The reason is that it's the result of numeric things. Like you tried to treat it like a number. And the result isn't a valid number. Like not a number should really be not a valid number. It's still a number in the sense of like how you created it and how you're using it, but it's just not a valid one. It's like dividing by 0. I would say the result of dividing by 0 as a number is just not one that we've experienced as mere mortals. Just need to open that third eye, and then you can start seeing nan as the number it truly is under the hood. Array, empty array, and null are objects. That annoying. Null being an object and undefined being undefined for type is silly. Like, here's a funny one. Undefined equals null, true. Type of undefined equals type of null, false. Beautiful, beautiful. To be fair, it's the same with numbers, like 1 equals 1, but type of 1 equals type of 1. Equals does the right thing in JavaScript, always. All makes sense. Nothing confusing here at all. Magically increasing numbers. Good old IE 754 2008 and good old binary floating point arithmetic. This one we've talked about a few times. I did a video about all the new fun things coming to JavaScript, and we have more precise math functions coming. And despite that, this still is the case where 0.1 plus 0.2 does not equal 0.3. This is not a thing that is just in JavaScript. Most languages that follow like the EEE standard for number math and floating point stuff are just wrong here. And that's reality. The things that we understand are not necessarily the ones computers do. Speaking of things that neither us nor computers understand, let's patch some numbers. You can add your own methods to wrapper objects like number or string. Number.prototype.isOne. Oh, let's have some fun. Number.toString equals 7. I am excited to try this. What happens if I do the following is the number 6 plus 6? Oh, I got too hopeful. I was really excited that that might work. Oh, is it number.prototype.toString? Fuck. It was worth a shot. I was hopeful. More hopeful than I should have been, probably. This one has bit me. Who else has been bit by this in particular? The fact that when you chain greater thans and less thans, it is evaluating the true or false there. So 1 is less than 2 is less than 3. That's true is less than 3. True is 1. 3 is more than 1. So that works. But 3 is greater than 2. That is true. 1 is greater than 1. False. Yeah. This is so awful. The only right way to do this is 3 is greater than 2 and 2 is greater than 1. Ugh. This has bit me so many times. Especially like advent of code type stuff. Oof. Not fun. Speaking of fun, let's do some funny math. Often, the results of arithmetic operations in JavaScript might be quite unexpected. Consider the examples. 3 minus 1, 2. 3 plus 1, 4. 3 minus 1 in a string, 2. 3 plus 1, 31. Empty string plus empty strings, empty string. Empty array plus empty array. This is the classic. This one's fun because the order of events matters. Object plus array, both empty, is 0. Array plus object is object. Obviously. Super logical. Super joyous. Just don't chain operators. It's not that hard. When you remember it, that's the problem with the comparisons here. This one works. So you might write this code, not think about it, and just think it works. And then you get some weird error later on. You're like, oh shit. And I think this should throw a syntax warning in most like linters still. Back to silly math though, because negative the string minus, that makes sense because of the string coercion. But like coercing this like that is super cursed. I guess it's the inverse of like plus 111. I still hate it. I still hate it a lot. What? Okay, I guess an array.toString, but if it's 44.toString, then it becomes 4, 4, which can't be coerced into a number properly. That makes sense. It's awful, but it makes sense. So if you're struggling to follow along on that one, when you do an operator between two arrays, it toStrings it, and then it tries to coerce that into a number. So it runs toString, and then it runs effectively parse int after that. This does mean we can try something else though. We'll do my favorite, return 7 plus 4 obviously is equal to 77. Now we're thinking with portals, boys. Wonderful. Isn't this beautiful? This is a great language. I love that we can override toString on all arrays. Obviously, every JavaScript developer has a really good use case for overriding toString. Let's try with like more numbers just to see if we can break this at all. What the fuck? You're not subscribed to Theo yet? You know it's free, right? Right? Guys, it's free to hit the sub button on YouTube. I'm putting all this work into going through all this cursed.js. Just hit the button. Half of you haven't yet. And the half of you that have, I appreciate you. Don't hit it again. Oh boy. Everyone's favorite. Regex. You can patch regex's toString. I hate this. I hate this so much. Fun fact, I actually did that in Fossabot v1. I patched regex. Strings aren't instances. Okay, capital string. To this day, I don't actually know if, when, where, or why you would ever want to use this. Okay, important question actually. Does string.prototype.toString exist? It does. Oh boy, I have to know. Const test string equals this is the right string. Fuck. I was hopeful. Wait. Fuck. You have to create it with string. So const str equals new string. This is the right string. Type of string is object because string capital S is not the same as string lowercase s. This is one of the many reasons to never use capital S string. But now if I do str plus hello, that works. But json.stringify str, it comes through as the wrong string now. Cool. New string str double equals string. Type of new string object. Object, what's that? Yeah, no, don't use capital S string. Never worth it. Only pain can be found there. Calling functions with backticks. What's sad is that this is actually useful, but nobody gets it. In case you're not super tuned into the Twitter drama web dev world, there was a drama not too long ago where Sam Selikoff showed off server actions, which is backend code that runs on your server using the use server call, which binds this as a post. So when you hit this button, a form action will fire that runs this code on the backend because this is backend code that just happens to render a UI and bind it via a form. But people saw this and they saw the await SQL insert into bookmarks slug values slug being passed in as a string. And their immediate assumption was that this was super vulnerable to cross-site scripting, to like SQL injects, to all the things everyone hates about the security of web dev, because they assumed this is code that just runs arbitrarily and dumps that in. They didn't notice is that the SQL call isn't wrapped in parentheses because this is a template function. It's a really cool thing in JavaScript. I actually think this is a good thing. So we'll see if the behaviors convince me otherwise. The way that this works is you're sending an array effectively between all of the things you pass in. So it's true is space, comma, whatever you passed here, comma, whatever the next thing is. But this is all an array. So you get the array with all of the things in the spaces, and then you get the rest of the stuff afterwards as values. So you have like function, sum func. This takes in args, console.log args. So we call sum func with like 1, 2, 3. Then we know args is going to be the array 1, 2, 3. Where things get interesting here is we call it this way. So we have first, and then we have 1, second 2, third 3. I'm going to throw this in our interpreter because now you'll see what happens. The first argument is an array that has the string up until the first variable, comma, the string after the first variable until the second one, comma, the string after the second variable until the third one, comma, whatever's at the end. And then the rest here, 1, 2, 3, this is the things that get interspliced between these. It's a zip function where you zip up the left and the right to make the official output. But this also means that you're getting all of these things as arguments that you can do whatever you want to. You can sanitize, you can validate, you can throw errors, you can check them. You're not passing a string blindly to some function. You're passing it all of the pieces it needs to construct whatever it wants to do. It's actually a really nice syntax for doing something like what we saw in that JavaScript code that everybody freaked out about. It makes it really easy to write SQL like this. Instead of having to write it the Python way, where you have the string, you have the like placeholders in the string, and then you pass the variables after. That's just a feature in JavaScript. And I think it's a good feature. I'm happy that we have this. Call. Found by Cramforce. This is the CTO of Vercel, by the way. So that's funny. I don't know how many of these were him. Call.apply. Insanity. This could break your mind. Try to reproduce this code in your head. We're applying call methods using the apply method. I don't want my brain to hurt any more than it already does. I'll leave that as an exercise to the reader. Const C equals constructor. C. What? Okay, so C is a string. Getting a constructor of the string. So C, function string. Getting a constructor of constructor. Oh, because yeah, it's constructor. That one threw me for a second. So if you have const sum string equals hello, sum string constructor, thinking is hard, okay? Because the constructor on any given string, I'm going to have like hello constructor. Why we have all these functions on strings? Bad decisions made a long time ago. Yeah. So this makes some sense now because you're passing constructor to the constructor of the string constructor. And then you're calling that with some code that gets evaluated. Ugh, chaos. Object is a key of object's property. No. Accessing prototypes with proto. This never has any issues. One, proto. This happens because when something doesn't have a prototype, it will be wrapped into a wrapper object using the toObject method. Okay, so the first time it's number. The second time, because there's no proto, it's empty object. The third time, proto of empty object is null. That kind of makes sense. If I do object.toString, what? Help In case you missed what happened there, this code works without a semicolon. It breaks with one. Destructuring with default values. Let x. X, y, 1, x. X, y equals 1. I hate this language. This one is hurting my brain. I need to just read the explanation. I was trying to reason through it and I can't. So what do these even mean? Okay, these are the steps here. So we declare x with no value, so it's undefined. Then we pack the value of x into the object property x. Then we extract the value of x using destructuring and want to assign it to y. If the value is not defined, then we're going to use 1 as the default value. Since x isn't defined because it wasn't defined here and we're using it here, we're going to use the value we have here as the default instead, which is 1. But in order to evaluate that has to do the y equals 1. And I think because we put the let here, it's letting us use an undefined variable there. That is my understanding here. To test my theory, I'm going to see if defining x ahead of time keeps y from being 1, because that code is never evaluate. What the fuck is this language? I'm moving on. Dots and spreading. I like spreading. It's going to ruin it for me. Spreading an array that is a spread of triple dot length is 3. Is that because spreading this is just a 3 dot? Yeah. Spreading a string turns it into the individual elements. That makes sense. That makes sense to me. That one's fair. Labels. Labels are really nice for loops. Let index equals 0. It will have a labeled while true. Console.log index plus plus. If index is 10, break labeled. So you can break within or without around other loops. It's very easy to get out. And if you're like nested in here, like imagine we were a different loop deep here, like we had a separate while true in here, which you might. We'll even just do that for the example. If I just did a normal break here, this gets run again. So I do like this. So here's what we'll do. We'll do let index equals 0. This code will run forever. I'll prove that by pasting it here and seeing if things crash. Labels are useful because when you put one here, you can say to break labeled. So if I paste this instead, it breaks. It is actually a really nice and useful feature, but I'm sure we're about to see how it breaks things. Because here, we're not labeling a while loop or a for loop or something. We're labeling a closure. Console.log first, break foo, console.log second, first, undefined. This is actually nice. This is nice. I like the fact that you do that with a closure. I don't think this is cursed. I think this is nice. Nested labels. Oh, it's getting less nice very quickly. I hate this now. I went from, oh, this is cool to, I hate this. Speaking of things we hate, let's do an insidious try catch. Try, return 2, finally return 3. The answer is 3. Why? The explanation, they don't even explain it. They just link you straight to the standard. They don't even try. Is this multiple inheritance? We're not talking about classes. Classes are cursed enough without JavaScript. Oh God, speaking of cursed generators, there's a video I've been putting off for a while. Function star is coming back. I notoriously don't like function star, even though I'm a functional programming nerd, because I have battle scars from using Redux Saga. And by using, I mean gutting, because I had to rip it out of a lot of code bases and it was not pleasant. Function star F, yield, next, totally typical generator here. As you can see, the returned value is an object with its value equal to F. In that case, we can do something like the following. Function star F, yield F. Yielding itself is scary enough. My functional programming brain is hurting from this one. Don't do this. Speaking of don't do a class of a class. It seems like we're declaring a class inside of a class. It should be an error, however, we get the string object. Okay, because like type of object is object. It's just, why? Literally everything JavaScript does with classes is wrong and bad. I hate it so much. I hate it so much. Non-coercible objects. With well-known symbols, there's a way to get rid of type coercion. Take a look. If value double equals null, throw type error. Non-coercible should not be called with null or undefined. Const res equals object value. Res symbol.toPrimitive. Fun. Can I call symbol.toPrimitive on things and use this to break like a equals 6? A symbol.toPrimitive equals 12. A.to string. Nope. Tricky arrow functions. Don't take arrow functions. You've taken so much from me, WTF.js. Do not take my arrow functions. It's all I have left. Oh, no, this makes sense, actually. Though this one's fine. Never mind. I don't like to use let for it, but whatever. What's going on here, if you guys don't know, is that JavaScript made an interesting decision early on where that is an object. That is a closure. What goes on here is code. Even if what goes on here is returning an array, what goes on here is code is executed between the brackets. There is a syntax to fix this, though. If you really want a function that returns an empty object, or a function that returns an object, wrap it in parens. There's actually a common mistake I see in like React code bases where somebody will be like, a const sum func equals. You can't call this. Well, you can, but we've just labeled the string hello with key. We haven't done anything real here. But if we want this to work the way you would expect, wrap this as follows. Make sure you assign it to a different value, sum func2. And now you get back the object. Just a quirk of arrow function design. It's not a big deal. Yeah, TypeScript will complain at you for this too, which is nice. Arrow functions cannot be a constructor. Yeah, that's kind of the point. Arrow functions are for people who have lifted themselves past this. I'm going to do a thing I'm going to regret. I'm going to open up the upload thing in for Codebase. I'll open some random save file, and I'm going to search for something that is going to hurt me. For every instance of this, God bless. Look at that. Giant code base, and we have two thises. How nice. Good job, Mark. Thank you. We're moving on because nobody needs this anymore. Let f equals function, return arguments. Cool. Now let f equals empty arguments. fa, arguments is not defined. Yeah, fuck implicit variables. The fact that arguments just magically exists when you have a function closure is stupid. That is dumb. This is not a good thing. Again, arrow functions stay on top. This is making me like arrow functions more. Return statements are also tricky. Consider the following. Function, return, new lined this. Well, yeah, you're returning nothing. But yeah, the return and the returned expression must be in the same line. Yeah, that makes sense. That's reasonable. Stupid that that's in here. Chaining assignments on objects. Okay, I think I get this one. It took me a second because this code is insane. Yeah, this is like order of events. So we set foo.x to foo, which is n equals 1. But then we set foo to n plus 2, which overrides whatever we did here with foo.x. So by this equals, foo.x is now n1. But then here, we override the current state of foo by setting it equal here. You ready for a real hot take? This is actually why const makes sense. I copy paste this code. It does exactly what they showed there. Makes perfect sense. But if I kill this and run again, console.clear, if we change these from vars to consts, this code will not work anymore because you can't assign foo again. You can't assign foo to n plus 2. So this is actually an argument for const being helpful. So once again, var and let kind of suck. Use const where you can. If you don't think the thing should be reassigned, you can escape from weird things like this. I'm not saying it's a catch-all. Not saying it's properly constant. I'm just saying it makes things a little less annoying like that. Accessing object properties with arrays. This is fun. If you pass an array in brackets to an object, what happens if I have two properties in here, though? Let's try it. RFD prop2 is 2. If I do this, it will work, though, right? Yeah, fun. And if I wrap this, is it because it's doing the toString? That's absolutely what's happening. So if I change this to be prop2, ta-da, figured it out before I read it. See, I'm catching on to your bullshit, JavaScript. You're just randomly calling toString on shit all the time. So that's what's happening here. When you have one object, the string that comes out is property, which works. But if you have two, the string that comes out is property, comma, whatever's next, which won't work. In this case here, is just calling toString on every layer. So the result is just property again still. Stupid, but it works, and I kind of get it. What about pseudo multidimensional arrays? Again, it's just combining these to strings. I figured your shit out. Number.toFixed, displaying different numbers. Well, we have to check something important. The only true browser, as you can tell by me using it very, very religiously. If I go to, I'll just go to Google. Let's open up a console. Does the hotkey work for that? Cool, it does. Look at that. We're using a real browser now, boys. 0.787. Cool. So everything's centralized but IE11. Cool. So IE11 rounds wrong. Everything else rounds right. Good to know. Nice learnings. Math.mac. Never mind. JavaScript was a mistake. What do I learn now instead? Oh, it's because math.min is infinity and math.max is negative infinity because it's not max value and min value. You're supposed to pass them an array. And if you don't, or you pass an empty array, going back to Dreambird. Good suggestion, chat. Comparing null to 0. Null double equals 0 is false. Null greater than 0 is false. Null is greater than or equal. I knew this one. I still hate this one. I'm not reading the explanation. Fuck this shit. Look at how long the explanation is for this one because it's so stupid. It's so stupid. Null is greater than 0 plus null equals plus 0. 0 is greater than 0, false. Nope. Same variable redeclaration. You can redefine vars, but not lets or consts. 1013.sort. This is a classic. When you call sort and you don't tell it what it's supposed to do, very fun. It always converts to strings by default, which is obviously what you want to do when you call sort. And now you have to write your own sort like comparator. Super logical, makes perfect sense. Everyone would expect that to be the behavior. Yeah, don't use bare sort. Never call sort without doing something to it. Absolutely agree. Resolve won't return promise instance. New promise, resolve reject, resolve the object, the promise.then, value equals object, true, console log value, A7. The value which is resolved from the promise is exactly the object. How about another input promise then? So if the object is a new promise, resolve 7, then we resolve this so it's like nested. The function flattens nested layers of promise-like objects into a single layer. This is just stupid. Don't do that way. Double empty object is undefined. Triple, quadruple, all is. Foo bar, empty. Is this a way to like get the keys from something? Yeah, I'm going to drop everything and go to Gleam after this. Fuck this shit. If you inspect foo bar, empty object after, you will find that foo bar is bar. There's two meanings for the open close brackets, an object or a block. For example, the brackets in here are a block. So use this to return an object. So foo bar is a block. Oh, since we don't have anything in front, that's a block. And this is a block too. So here we are labeling the string bar. It looks like an object, but this is the label foo on string bar and then an empty closure right after. Labels are great until they make your closures look like objects. An alert from hell. Okay, so this is an alert encoded by octal escapes, and then we evaluate it as a function. Fuck that. An infinite timeout. Set timeout infinity, and it gets called immediately. Usually, runtime stores the delay as a 32-bit signed integer internally. This causes an integer overflow, resulting in the timeout being executed immediately. Why doesn't it give an error when you call it with a number that's not a 32-bit signed integer then? Just throw an error. Well, it's going to break things now, but just throw the fucking error. A set timeout object. Guess what happens if we set a callback that's not a function to set timeout? Window or worker global scope.set timeout can be called with code as the first argument, which will be passed on to a val, which is bad. No way. Refuse to evaluate a string as JavaScript because unsafe eval is not allowed, source or script. Okay. So if you have a content policy set, you can't do that. But if you don't, then it will try to eval it. Fuck all of that. Double dot. Let's try to coerce a number to a string. 27.toString, unexpected. 27.toString. The dot character presents an ambiguity. It can be understood to be the member operator or a decimal, depending on its placement. So does putting the dot here make it a float and then you can toString it? Oh, it's because 27 dot could possibly be additional numbers after. Double, not float. Thank you, yeah. Because like you do 27.2, and that's a float. 27.toString is a float it can't evaluate. But if you just do 27 dot, now that's a double. That's a 27. So 27 dot toString. I hate this language. Classes again. New foo dot val. Yeah, you can call new a whole bunch. It doesn't give a shit. I knew that already. I knew about new. Split a string by a space. I've never tried to split an empty string by a space. When you pass an empty string, it will never find the separator and thus return that string. But it never finds this either. Okay, so if I have like const sample equals 1, 2, 3, 4, 5, sample.split, this will split it into 1, then space, then 2, then space, or not. Empty string, it will do that. Then it does that, and this doesn't. I hate this language. I vaguely knew this, but this makes no sense. So dot split, nothing. That is way more cursed. Empty string.split on undefined gives you an empty string. Empty string.split on empty string gets you nothing. Empty string.split on empty string with a space. Last thing to test then would be empty string.split. Okay. Everything makes sense but the empty string on both sides case. I feel a little bit better here. This one makes no sense. Everything else kind of does. Substrings are determined by searching from left to right for occurrences of separator. These occurrences are not part of any string in the returned value, but serve to divide up the string value. That does not help with explaining that one case at all. A stringified string. We had fun with this earlier. JSON with stringify production. That's because this gets double wrapped, right? Yeah, that's why. Versus production, single wrapped. That makes sense. That is not weird. That is what it should do. JSON is different from strings. JSON is a string, but JSON is not the same thing as a string. That one's stupid to be in here. Non-strict comparisons of a number to true. Never a good idea. We've been over why. Did we make it? Have we now seen all of the terrible things in JavaScript? I mean, the answer to that is no. There's always more terrible things in JavaScript. But at the very least, I got through this list. I hope this was fun for you because it was miserable for me. Maybe the result will be a good video, though. Let me know in the comments if it was. And until next time, peace, nerds.